Hello everyone, this is Heading Tian. Welcome back to my video. Today in this video, we are learning 1.9, solving absolute value equations and inequalities. Let's see the definition of absolute value. The absolute value of a number is its distance from zero. Distance is always a positive number. For example, if I have absolute value of x equals 4, I draw a number line. In the middle, I say this is 0. So if you see these two hash lines, that means we are looking for the distance from the x to 0 equals 4. You have a point here, which we say this is x. From the x to 0, the distance is 4. So x is 4. From 0 to x is 4, x is 4. I also have another x. The x could be here. Then if I have a tape or I have a measure tape, I can measure that. From here to 0 is also 4. So the x is -4. X could be 4, could be -4. Let's see, solving an absolute value inequality equation. Step 1, isolate the absolute value. That is, write the equation in the form of absolute value of x equals a, where a is a real number. For example, if I have 2 times absolute value of x equals 4, I need to isolate the x first, get rid of the 2, divide it by 2 both sides. Then absolute value of x equals 2, because we know this is 2. Then solve for the x. Second step, if a is less than 0, okay, if I have this, absolute value of x equals -2. -2 is less than 0, negative number. So the 2 hash line means distance. Can I say distance be a negative number? No, we don't have a negative distance. There's no solutions for x. Number 3, otherwise, if a is greater than or equal to 0, rewrite the absolute value equation as x equals positive a or x equals -a. That means if I continue to solve for my x equals +2 or -2. So that this means positive or negative. Okay, number 4. Solve the individual equations from step 3. We solved that. Number 5, check the answer in original absolute value equation. Let's use the 5 steps to find the variable's value. Number 1, absolute value of p equals 7. So we know that 7 is greater than or equal to 0. So p equals 7 or p equals -7. You can also write it into this way, p equals positive or -7. This is 2, not 7. Or you can list 7 and -7 in the set notation, 7, -7. So in your exam, you can give me this answer, or you give me this answer, or you give me this answer. You all get the credit, full credit. Don't worry if you didn't write the correct form, but on my math lab, I think my math lab prefers the set notation. Next example, absolute value of x equals -7. So distance equals negative. That's impossible. So there's no solution for this one. If you use set notation, you can put a phi. That means empty set. So you can write this one or you write this one. Next example, absolute value of x equals 0. So the distance from x to 0 is 0. That means x is a point 0. So I don't need to move it here or move it here. The distance from the point to 0 is 0. X only have one solution, is 0. Next example, absolute value of y minus 3 equals 12. That means from everything in the absolute value to 0 equals 12. Okay, that means y minus 3 equals positive 12, or y minus 3 equals negative 12. Then we can solve these two equations separately. So we add 3 both sides, y equals 15, or another solution, add 3 here, add 3 here, y equals 9. Oh, sorry, negative 9, because we have negative 12 here. You can put them in the set notation, 15, negative 9. I think I read them too big. Okay, it doesn't matter. So next one, absolute value of 2x minus 3 equals 4. That means everything in the absolute value, 2x minus 3 equals positive 4, or 2x minus 3 equals negative 4. So solve these two equations. Add 3 both sides, 2x. Okay. Add 3 both sides. 2x equals 7 divided by 2 both sides. X equals 7 over 2. Another equation, we add 3, 2x equals negative 1 divided by 2 both sides. X equals negative 1/2. Okay, that's how we solve the absolute value equation. Next part, absolute value inequalities. So let's see this. For example, if I have a expression, I say x equals 3. I know that I solve it x equals positive negative 3, because on the number line, this is 0. From 3 to 0, the distance, let me make it looks better. So from 0 to 3, this is 3. And from negative 3 to 0 is also 3. Now here is the question. If I have absolute value of x less than 3, where to choose the set, the solution set? Can I choose a point here? Then from, so the x is here. From the x to 0, this distance is less than 3. Yes, it satisfied this condition. If I choose the x here, from the point here to 0, that point to 0 is, the distance is less than 3. Yes, satisfy this condition. If I have a point here, from this point to 0, can I say it satisfied this condition? The distance is less than 3? No. So I can't choose a point here. I must erase this and oh, I erased everything. So I can only choose a point here, 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 and then any point to 0 can satisfy this condition. Distance is less than 3. That means if I use a parentheses contain this area, the absolute value of x is less than 3. I can only choose point in this area. Okay, let's move back to the definition. Absolute value inequalities. Let's A is greater than 0 if absolute value of x is less than A. Then x, the solution of the x is bounced between negative A and A. So here is 0. So x could only be in this area. between -a and +a. Let's use this definition to solve two questions here. Number 12, the absolute value of t is less than or equal to 3. That means here is -3, here is +3. I can only choose a point in the middle, then the distance is less than 3. And also we have an equal sign here. That means I can choose the point t equals -3 and t equals -3, +3 and -3. So t is between -3 and 3. In the set notation, how to write it? In the interval notation, we write the t is between -3 and +3. We use brackets, -3 and +3 brackets, because these 2 points, they are included in my solution. And you find the point on number line, -3, +3. Use brackets, highlight in the middle. Next example, the absolute value, or I say the distance from t to 0 is less than or equal to a negative number. Can you say a distance less than a negative number, or a distance can be a negative number? No, distance is always be positive or equal to 0. So if the distance less than a negative number, there's no solution. Or interval notation, you just put an empty set, you saw 5, no solution. Next example, absolute value of x minus 1 less than or equal to 2. So everything in the absolute value is between -2 and +2. And solve for the x, we need to add 1, because at the end I must have isolated x, just a single x. So we can add 1 here, add 1 here, add 1 here, everybody add 1. X is between -1 and 3. You can find -1 here, find 3 here. So x is between -1 and 3, highlights the number line between them. Is between -1 and +3. Let's see, next inequality. 2x minus 6 is between -8 and 8. Solve for the x, add 6. 2x is between -2 and 14. Divided by 2, x is between -1 and 7. So on the number line, -1 here, +7 is here. Use parentheses because -1, 7, they are not included. Highlight the number line between them. The interval notation is -1, +3, parentheses. Next part is greater than. Okay, in previous examples, we say absolute value is less than. How about greater than? For example, if I have absolute value equals 6, I know that the x equals positive or -6. So here is -6, here is +6. If I'm looking for the x, absolute value of x is greater than 6. So the distance from the x to 0, if I pick a point here, for example, here is the x, from the x to 0, yes, it's greater than 6, because from -6 to 0 is 6. So this one works. And a point here from the x to 0 is greater than 6. So this point also works. So, but the point here to 0, point here to 0 doesn't work. That means I can only choose a point on the left-hand side of the -6, and on the right-hand side of the +6. So we can list two inequalities. One is x is greater than 6, or so greater than 6 is this area, and x is less than -6, or I say x is greater than the big number and less than the small number, negative number. And then we can write them in the interval notation. Okay, let's come back to the definition. Let's a is greater than 0 if absolute value of x is greater than a, then x is greater than a, or x is less than -a. So x could be in this area or in this area. Let's see the example. Absolute value of x is greater than 6. We have solved this one. X is greater than the big number 6, or x is less than small number -6. So find them on the number line. Here's 6. Oh, sorry, -6. This is the +6. X is in this area and in this area. The interval notation. So from the smallest number to the greatest number, we have -infinity to -6. And also you need to have a union this area from 6 to infinity. Next example, the absolute value, the distance is greater than -6. Yes, it's always true because the absolute value or the distance from x to 0 is always positive. Of course, it's greater than any negative number. I can also say absolute value of x is greater than -2, or -3, or negative infinity. So if we have this, that means all the real number works in this condition. We say all real numbers, or in your homework, you use the interval notation, everything on the number line from -infinity to infinity. You can highlight the whole number line like this. The interval notation, -infinity to infinity. Okay, let's see next two examples. Oh, these are last two examples. So let's solve this. Absolute value of x minus 1 is greater than or equal to 4. That means x minus 1 is greater than or equal to 4, big number, or x minus 1 is less than or equal to small number, -4, and solve these two inequalities separately. So add 1 both sides. X is greater than or equal to 5, or add one here, x is less than or equal to -3. Let's find these two numbers on the number line. So here is -3, here is 5. So x is greater than 5 is on the right hand side of 5. So highlight this area. And the x is less than or equal to -3. We highlight this area. Oh, be careful one thing. This is greater than or equal to what symbol I must use. I must use the brackets. So use brackets, then highlight this area. From the graph, I know that interval notation is from -infinity to -3. And brackets, union brackets, 5 to +infinity. Okay, next example, absolute value of 3x minus 8 is greater than 7. Let's solve this one. Everything in the absolute value, that's 3x minus 8 is greater than big number 7, or 3x minus 8 is less than the small number -7. Solve the inequalities. We add 8 both sides. 3x is greater than 15 divided by 3. X is greater than 5. Another inequality, add 8 here, add 8 here. 3x is less than positive 1. So divided by 3, both sides. X is less than 1/3. Let's find them on the number line. Here is 1/3. Here is 5. Greater than 5, there's no equal sign. So we have parentheses. Highlight this area. Less than, so less than negative, less than 1/3. So we need to highlight all the number on the left hand side of 1/3. And we have parentheses because these two numbers, they are not included. For the for the interval notation, is from -infinity to 1/3. Union 5 to +infinity. Make a better union. Okay, that's the last question of 1.9. We finished the chapter 1 or unit 1. So I hope you can be prepared for the first exam. If you have any question, you can ask me. If you are in my face-to-face class, you can ask me after the class or visit my office hour. You can also join my online office hour or email me. Okay, good luck and have a good day. See you next video. Bye.